Hello everyone, welcome to this presentation on understanding file systems and operating system, focusing on FAT, NTFS and extended. I am Manasvi Saxena and today we are going to explore how data is stored, managed and accessed through different file systems. Now, what is file system? A file system is a method in operating system which is used to organize data and manage data. It defines how data is structured, how directories are maintained, and how space is allocated. Now think of a file system as a librarian of your computer. It not only stores books but knows exactly where each one is placed, its author, and who can access it. For instance, when you save a Word file called resume.docx, the file system instantly records where it's saved and how large it is and who can open it. Now, why file systems matter? File systems directly impact the integrity, speed, and security of your data. Features like journaling help prevent corruption by keeping logs. They improve performance by organizing how data is read and written. They enforce security through permission and encryption. They also determine how well your system can scale and whether it will be compatible with other platforms. Now, for example, imagine you are writing a school project and the power goes out. Without journaling, your file might be lost or corrupted. But with file systems like NTFS or Extended 4, it's like having an autosave feature. Changes are logged before being finalized, helping recover from caches. Now let's take a quick look at how file systems have evolved. In 1977, FAT was introduced for early DOS systems. In 1993, Microsoft introduced NTFS with journaling and security features. On the Linux side, Extended has been evolving since 1992. More recent innovations include ZFS and BTRFS with features like snapshots and Apple's APFS, which is optimized for SSDs and strong encryption. Now we'll discuss about FAT file system. FAT, or we can say file allocation table, is one of the oldest file systems. FAT16 supported file sizes up to 2 GB, while FAT32 increased this to 4 GB. Extended FAT, released in 2006, removed the 4 GB file size limit. FAT systems are highly compatible with many devices, making them great for USB drives and SD cards. However, they have drawbacks. They don't support journaling, making them vulnerable to corruption, and they don't offer much in terms of security. Like, for example, ever tried copying a 5 GB movie onto a pen drive or received an error? That's because FAT32 can't handle file over 4 GB. Extended FAT solves this problem. Now let's discuss about NTFS file systems. It is default file systems for Windows. It introduced journaling, meaning it keeps a log of changes before they're made. It also supports access control list for security and offers features like file compression, encryption, disk quotas, and hard links. NTFS is extremely scalable with support of huge files and volumes. Like for example, when you set a folder so only you can open it, you're using NTFS permissions, or when Windows asks you for admin rights to delete a system file, that's NTFS enforcing its rules. Now let's talk about extended file system. Uh, Extended, which is also called as EXT, is native to Linux. Extended 2 released in 1993 lacked journaling. Extended 3 fixed that in 2001. And Extended 4, now the default, came out in 2008. It brought in support for larger files, journaling, delayed allocation, and better performance. If you're ever used an Android device, you've used extended, your apps and medias are stored on partitions formatted with file systems like extended 4. Now we'll see how file system works. The boot sector is the first thing your system reads to know what file system is in use. Then file metadata, it's stored in structures like the master file table in NTFS or in nodes in extended. Data is stored in blocks and the directly structure keeps everything organized. Journaling logs changes before they're committed to disk to avoid loss during system crashes. For instance, when you open a file folder full of images, your OS looks at the file system's metadata to find and display each image instantly, even if they're scattered across the disk. So now this is the comparison table between FAT32, NTFS and extended 4. Now maximum file size, it is 4 GB in FAT32, 16 EB in NTFS and 16 TB in extended 4. Maximum volume size 2 TB in FAT32, 256 TB in NTFS and 1 EB in extended 4. Now talking about OS compatibility. So FAT32 is the most widely compatible file system. It works well with Windows, Mac OS and Linux and Android. Because of this, it's steals for USB drives and SD cards. However, it has limitations like a 4 GB maximum file size and no support for permissions or journaling. Now, NTFS is the default file systems for Windows. It supports large files, file permissions, compression, and journaling, making it suitable for system drives and internal storage. Talking about extended 4 is a standard file system for most Linux distribution. It supports journaling large partitions and is highly reliable for Linux-based systems. However, extended 4 is not supported natively on Windows or Mac OS. You need third-party tools to access it. Now we'll see limitations of each file system. So talking about FAT is prone to fragmentation and has a small size limits. Extended to, though fast, doesn't have journaling. NTFS isn't natively supported on other systems and may require third-party software. Over time, performance can degrade, permissions may conflict, and corrupted blocks can affect data. Now, for example, if you unplug a USB drive before ejecting, FAT might corrupt your files. NTFS would have logged the change and possibly recovered. Now we'll see when to use each file system. So FAT32 is ideal for older and simpler devices. Extended FAT is better for external storage with large files. NTFS is great for internal drives, especially on Windows. Extended 4 is optimized for Linux machines and performance well on servers and database. Now, these are some real-world file system applications. Linux servers use extended 4 for high-performance workloads, cloud infrastructure, or database storage. Windows uses NTFS to manage everything from desktops to enterprise networks. FAT or extended FAT is a go-to for pen drives, memory cards, and external drives due to their universal compatibility. For example, Amazon AWS server use extended for your Xbox stores game files using NTFS, and GoPro memory card is typically formatted as extended FAT. Now, there are also new file systems are emerging with powerful features. Like BTRFS used in Linux supports snapshots and self-healing. ZFS is widely used in data centers and offers robust data productivity. APFS used in Apple devices supports encryption, space sharing, and fast cloning. For instance, a Apple's Time Machine uses APSF snapshots to let users restore deleted files or roll back after failed updates. Now let's get to the conclusion. File systems are the foundation of how your device operates. They affect everything from performance to security. Choosing the right one depends on what you need. It can either be speed, compatibility, or long-term stability. A software developer might use extended 4 on Linux for speed, but NTFS for dual booting with Windows. And a casual user might prefer extended FAT for flexibility between different operating systems. So now thank you so much for joining me. I hope this helped you understand what happens every time you click save on your computer. So that was all from my side. Thank you.